going to give you a problem. You are 50 meter above the ground, negative 50 meter, and you are at location 1. You're throwing something in the air like this. So this is the vector. This vector is initial velocity 20 meter per second. And understand the angle of this vector. The angle of this vector is 90 degree. 90 degree with respect to what? With respect to the ground. To do velocity, v, velocity, initial velocity, vix, viy. Then you can write vi, vi. How can you write x? Well, cosine theta. How can you write y? Well, sine theta. What is theta? Of course, 90 degree. What is theta? Of course, 90 degree. So, what is vi? Vi I gave you 20. Okay, so 20 cosine 90 is 0. 20 sine 90. 20 sine 90 is 20. Okay, so all the velocity at the y direction, no velocity at the x direction. By the way, what is the range? The range is 0. It looked like range is not 0, but range is 0. Look, this is what happened. If I throw this object and it lands on my hand, then how much does it move at the x direction? 0. Okay, this is close to what it should look like. But if I do draw it like this, then I can call it location 1, no problem. I can call it location 2, no problem. But I cannot call it location 3. Then location 1 and location 3 would look like same. So I'm going to exaggerate a little bit. Although this looked like this because there is no Vx. If there is no Vx, there is no dx. There is no Vx because there is no Ax. 1, location 2, location 3, location 4. This is negative 10, this is negative 10, this is negative 10, this is negative 10. Right? This is 0, this is 0, this is 0, this is 0. Acceleration due to gravity at the x direction is 0, always, no exception. We also can say Vx is 0. Right? We also can say dx is 0. Okay, so you see the connection. If Ax is 0, Vx is 0. If Vx is 0, dx is 0. Good, everything is 0 at the x direction. Nothing is going on at the x direction. This is 0. At location 1, t is 0. At location 2, this is location 2. Velocity at the y direction is 0. How do you know? Because object is changing the direction. At location 2 is equal to vi plus at. At location 2, vf is 0. It changes the direction. Maximum height, location always 0. vi is 20 minus 10t. So t is 2. So this is 2. If from here to here is 2, here to here is also 2. Why is that? Because this is the parabola. This is the vertex. So you're going to write 4. However, this is not the part of the vertex. So we cannot write 6. No, we don't know how long does it take. Okay, so we're going to use quadratic. Why quadratic? Because if there is an acceleration, it is always quadratic. So d is equal to vit plus half at squared. So this is negative 50 is equal to 20t minus 5t squared. So this is t squared minus 4t minus 10 is equal to 0. So you're going to use the quadratic formula. So 4 plus minus 16 plus 40 divided by 2. So 4 plus minus 56 divided by 2. 56 is between 64 and 49. So which is 7 and 8. So this should be 7.5. So I'm going to use 4 plus minus 7.5 divided by 2, which is 11.5 divided by 2, which you're going to say 5.8 divided 5.8. So final time is 5.8. Time over here is 5.8. 5.8. Okay, great. dy. What is the dy over here? 0. dy over here, vf squared is equal to vi squared plus 2ad. At right here, velocity is 0. You want to find this one. This is called max height. Max height from 0, 0. Okay, vi is 20 squared minus 20d. So d is equal to 400 divided by 20, which is 20. So dy is 20 at location 2. So dy is 0 over here and also negative 50 over here. Okay, now let's find the displacement. This is 0, this is 20, this is 0, this is negative 50. Vy, let's find the Vy. Vy is 20 over here. 0 over here. Why is 0? Because it's changing the direction. Vy is negative 20 over here. We want to find the Vy over here. Vf is equal to Vi plus At. So Vf is equal to Vi 20 minus 10, T is 5.8. So Vf is equal to 20 minus 58. So this is Vf is equal to 38. So this is 38, negative 38. Okay, great. Now Vxy, so this is 20, okay. How do you find Vxy? Vx square plus Vy square. Okay, this is 0, so then this is going to be just absolute value. Okay, 0. Vx is 0, this is the graph. This is 20, this is 20, this is 5.8, this is 4, this is 2, this is negative 20, this is 38. Okay, this is 38, right? Is that 38? Negative 38. This is half BH. This is BH. This is half BH. So this is 20 plus this is 20 plus this is 35 plus this is negative 15. This one cancel, negative 15, negative 15. So this one is equal to what? This displacement. And this is negative 50. Okay, great. This is average velocity. So what is the average velocity? Okay, so this is average velocity. Okay, so this is average velocity. Average velocity is df minus di over t. df is minus 38, minus 38. df is minus 50. da is 0. T is 5.8. 0.6 meter per second. So this is average velocity, negative 8.6 meter per second. This is also average velocity. Average velocity, which is Vf plus Vi over 2. What is Vf? 38. What is Vi? Well, negative 38. What is Vi? 20 divided by 2. So 18 divided by 2, which is 9. Well, this is also 9. Okay, so this is average velocity, which is 9. Okay, now let's do distance versus time and speed versus time. This is the distance versus time. Speed versus time. This, okay, at 2 seconds is 20. 5.8 seconds is 90. Okay. Why 5.8 seconds is 90? Let's see. From here to here is 20. From here to here is 20. From here to here is 50. So total is 90. Okay. Now speed versus time. Take the slope of this one. No. This is, take the slope of this one. Slope of this one. So the slope of this one is 20. Take the slope of this one. Okay. I should draw it like this. Yeah, like this. Like this. Wow. Wow. This is great. So then it should bend like this. Like like this. Yeah, so you can draw a tangent line. So that would be 0. Okay. Oh, good. So this is, oh, wow. Perfect. Look, perfect. Perfect. This is perfect. Okay, this is perfect. Okay. All right, great. So then At 20, uh, okay. So here velocity is 20. At 2 second, velocity is 0. At 5.8 second, velocity is 38. Okay. So area. So this is 20. This must be 70.